Afternoon, guys. Okay, so today we are going to be starting with exponents, and that's going to lead us actually into rational expressions. I kind of thought you guys might like the redneck mower here. And no, this I don't believe really happens in real life, but hey, looks funny. So anyways, we're going to just look at the exponent rules real quick, and I want you to make sure you have all these written down. And I'm going to be expecting that when you do your problems, that for each rule that you use, that you actually write down what rule it was you used. So we're going to be looking for this one at, the first one is multiplying the bases. And basically it's if you have x to the some exponent, in this case we're going to call that exponent a, times x to an exponent b, we're going to say that equals x to the a plus b. And I am not sure why half my word is gone here. Interesting. I need to read that. There we go. Okay, so the next one is dividing the bases. And that's going to be x to the a power divided by x to the b power equals x to the a minus b. So you're going to subtract the exponents. Then you have power to power, which basically means you're raising one exponent to another. So I have x to the a power, and I'm raising that whole thing to the b power, is going to give me x to the a times b. The negative exponent, and I chose to show this one slightly different than probably what some of you have seen in the past, because it probably a little more clearly represents what you're doing here. So I have x to the negative a times y over x to the negative b. What you're doing here, you can tell, is you're actually taking only the base and the negative exponent, and you're moving those to the other side, and you're making the exponents positive. So x to the negative a goes to the bottom and becomes x to the a. The y stays here though, it doesn't move because it has a positive exponent, and then the z to the negative b goes to the top and becomes z to the positive b, giving you an answer of y times z to the b power over x to the a. The last one is just a rule. Anytime you raise anything to the 0 power, it's always going to be 1. Okay? So now when we look at our problem here, the first one, we have 2b to the 4th over 2u to the 3rd b squared times u squared b to the negative 3rd, and we're raising all of that to the 4th power. There's several different ways you can actually do the simplification. So I'm going to actually start, for me personally, I would like to simplify everything that's inside the parentheses first, and then I will do the exponent on the outside. So here, so we see this as multiplication, and if you remember, multiplication is commutative and associative, so I can reorganize this however I would like. Alright, so I would actually start, and I'm going to combine v squared, u to the 3rd, and u squared, and v squared and v to the negative 3rd. I can combine those, and that's going to give me 2v to the 4th over 2. I have a 1 here, so it's just 2 times 1, so it's 2. U to the 3rd plus the 2, and v squared plus the negative 3. Now I'm going to actually do this in 2 steps. So that would be my first step, but here we'll go ahead and write the simplified form, which is 2v to the 4th over 2u to the 5th, v to the negative 1st, and we're going to raise all that to the 4th power. And this first step here would be, I'm going to actually just abbreviate it, it's the multiplying the bases. Okay? And now I'm going to go ahead and I'm going to actually, you can do one of two things. I can move the negative to the top and then add them, or I can use the dividing bases rule and do the subtraction, which is what I'm going to do. So this is going to be 2b to the 4, and this is minus negative 1 over 2u to the fifth. And this actually equals 2b to the fifth over 2u to the fifth. And this, I'm going to use this as the dividing basis. And I'll actually abbreviate the dividing. Okay, and this is still to the fourth power. Alright, now I'm going to go ahead and simplify this here. There's actually one more thing I can do right off the bat that's, I guess you could consider dividing the bases as well. These 2's will cancel out, because if I do it, it'll be 2 to the first minus, and this is 2 to the first, it'll be 2 to the first minus 1, which is 2 to the 0, which we just said is 1. Okay? And if you aren't understanding what I just said there, please write it down and ask me about it tomorrow. So this is going to be b to the fifth over u to the fifth, all to the fourth power. And now you do multiplying the exponents. So this is power to power, so this is b to the 5 times 4 over u to the 5 times 4, which is b to the 20 over u to the 20. And this one here was power to power. And this actually gives me my answer right here. Okay? So that's a rundown of the first one. And there's several different ways you could have done it. You could have done the power to power first. You could have done several other different ways. I don't want to say different ways. It's all using the same rules, but it would have just been doing it in a different order. Okay, so when we look at number 2, we have y to the third raised to the third times x to the fourth, y to the negative fourth, all over x squared, y to the fourth, z to the negative second. So I'm going to do this one in a little bit of a different order here. The first thing I'm actually going to do on this one, just to show you a different way, is I'm going to take my negative bases and my negative exponents, and I'm going to move them to where they need to be first. So I'm going to take, I'm going to rewrite this. This is going to be y third to the third times x to the fourth, and I moved z squared up, and y to the fourth went down. So this is x squared times y to the fourth, and this was y to the negative fourth, so it becomes y to the fourth. And this was the negative exponent rule. Okay. Now I'm going to go ahead and I will do the power to power. So this is y to the 3. Remember, you're multiplying, so this is y to the 9th times x to the 4th z squared over x squared times y to the 4th times y to the 4th, and this was the power to power. I'm just going to put p to p. Okay, power to power. Now I'm going to go ahead and I'm going to use the multiplying bases rule. So this is y to the 4th and y to the 4th. So we got y to the 9th, x4, z2 over x2, and 4 we're adding them, so that's going to be y to the 8th. And this was the multiplying basis. Okay. Now I'm going to go ahead and draw a line here. So now you have x4, x2, y9, y8. We're going to go ahead and at this point, sorry about that, I keep bumping it. At this point we're going to use the dividing bases rule. So this is going to be x4 and x2 you're going to subtract. So that's x4, 4 minus 2 is going to be 2. 9 minus 8 is 1. And then the z squared is by itself. And that gives me my answer. And actually here, let me go ahead and I'm going to actually write it so that you can see it. So this would be x4 minus 2, y9 minus 8, and z2. And this here would go above, okay? But this would be the dividing bases. All right? And you noticed how here I had y first, x, then z, and I just rewrote it with the x first, the y, then the z. All right? So there's a couple different ways of doing it, but the important thing is one, I want you to have those rules written down, and then I also want you to write them as you're doing them, because this will help drill into your head what the rules are and when to use them and when not to use them. Okay? And again, like I said, there's other ways you could have done it. We could have actually not even used the negative exponent rule. Probably we'd have to see, but we could have done the dividing bases rule, and it might have gotten rid of them, and it may not have. So it's just there's many different ways you can do it. It's just what you feel comfortable with in the order in which you do it. Okay. So hopefully you guys understand this. Please write down any questions you may have and ask me tomorrow in class. I will not be here on Friday. So hopefully you do these and come to class tomorrow prepared to work. Have a good night.